Hi guys, today we'll be discussing about the tutorial for week 4. Question 1. How many clock cycles the ALU needed to perform addition and subtraction? Write down the required steps for both the addition and subtraction. Okay, so before we start, we'll look at the stimulation done on the Tinkercad circuit. At first, this is the bus, this is the clock of the circuit, this is the register A, this is the register B, and this is the output on register A and register B, and this is the ALU, and this is the output of the ALU, and this is the switch where this will enable us to choose whether we want to add or subtract the value on the register A and register B. Okay, so firstly, we will load the number we want to add to register A, that we want to input to register A at the bus, and after we do this, we will set the load here to high. By doing this, the data on the bus will be loaded to the register A. After it's loaded, the load should be turned off immediately, and then after this, the data that we want on register B will be set on the bus, and the load will be turned low after that, turned high after that, and the bus here, the value at the bus will be outputted to the register B. And once this is done, the load should be again turned off immediately, and in this circuit we will be performing addition. So the switch will be turned to the EU side, and by doing this, the value at register A and register B will be added. And for example, for this circuit, we will be using 15 and 3 as example. So the 15 is at register A, the value at register B will be 3, and 15 plus 3 will be 18, and this can be seen at the output of the ALU. And now this is a subtraction. This is quite similar to the ALU addition circuit that we've seen earlier. The only difference is that after we load the data we want to register A and register B, which is the same as just now, we set the switch here to subtract instead of adding. So by doing this, the value at register A will be subtracted by register B, and for example, this will be using 15, 15 and 3. 15 minus 3, the number of value we get will be 12. So now we will be looking at the timing diagram for the subtraction. As you can see here, operation 1 will be pull low. The value 0 times 0, 1 will be pull low into the bus. Operation 2, the load pin will be pull low in order for the content at the bus to store at register A. Operation 3, pull the value 0 times double A into the bus, and operation 4 is pull load the load pin of register B so that the content at the bus will be stored at the register. The fifth operation of the ALU subtraction will be the SU is pulled high in order to subtract the data in register A and register B, and the operation 6 will be the result of subtraction is outputted to the bus. By assuming that the loading of data from register A to the bus and register B to the bus will take up 1 clock cycle each, the ALU subtraction will be done in 2 clock cycles. As you can see, this is the timing diagram. At first, the data is loaded into the bus, and once the data is loaded to the bus, the enable will be set low, and then the data at the bus will be inputted to the register A, and then after that, the data that we want to input into register B will be set at the bus, and then the enable at register B will be turned low again. And then as you can see, after we turn low, the data register at the bus will be outputted to the register B here. And then after this, the data is inputted to the register A and register B, the SU is turned high. And then when we do this, the value of register A and register B will be subtracted. As you can see, the ALU output will show the value that we subtracted, and when we obtain the value, the sum of the ALU will be outputted back into the bus, and this can be shown at the 6th clock cycle.